All right, today we are going to do section 11.2. We are going to use properties of a tangent to a circle. At how many points does a tangent touch a circle? How many times does a tangent touch a circle? One time. A tangent will touch a circle at 1 point only. For our warm-ups, you do not need to write out the questions. You will need to copy down the diagram for number 3 and show any work that we show. What's the plural of a radius, Jaden? Radii. That's something we covered yesterday. Describe how a radius and diameter are related. Ken.
They both have to do with how to find the circumference.
We can use them to find the circumference. Jaden, how are they related to each other? That is true about both of them, but it does not relate to them. A radius and a diameter are related because a radius is half of the diameter. So if I ever ask you that again, I either need to know that the radius is half of the diameter or that the diameter is twice the radius or 2 times as much as the radius. If I ask you that question on a homework quiz, a quiz, a test, anywhere, and you just say they have to do with circles or they both touch the center, you're not getting any points. That doesn't relate them to each other. On number 3, we have to use the Pythagorean theorem because we have a right triangle. So we use a squared plus b squared equals c squared. This is an idea that we are going to have to use today, even though we're dealing with circles. It's going to come back today. So what do I plug in for a? 6 squared plus what's going in for b? A b, or if you want to change it to an x, you can. And then what's going in for c? 10 squared. 6 squared. 10 squared. How do I get b alone? And then? So b squared equals 64. We have to square root, which means b does equal 8. We have to be able to solve right triangles to do today's lesson. All right, these theorems are, as you probably noticed, very highly related to each other. It just works in both directions. So the first one says if a line is tangent to a circle, so in the diagram we can see line L is tangent to our circle, then it's perpendicular to the radius drawn at the point of tangency. What is our point of tangency in this diagram? B. That is where the tangency occurs, so that's where they drew the radius to the center. So that radius is perpendicular to the tangent line. How do we know that it's perpendicular from this drawing? Because of the right angle. Now, we can also reverse it. So in a plane, if a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. So we could know that this line is definitely tangent if we can prove that there's a 90-degree angle there. It works both ways. All right, so I'm going to take away our other circles for just a minute so we can focus on just our first example. I believe that one's already on your notes for you, so you do not have to sketch it. We are asked to solve for the variable. Now this problem's nice because they went ahead and set up what kind of triangle for us? A right triangle. So even though they did this with a circle involved, we really don't need the circle part there for us to be able to do this problem. This is way back whenever we covered Pythagorean theorem the first time. It just keeps coming back. So we go to a squared plus b squared equals c squared. What am I plugging in for a? Okay, 15 for a. What about b? X squared. And then for c? Why does c have to be the 17? It's the longest side, and we know it's the longest side because it's across from the right angle. So it's the hypotenuse. It's got to be c. Now we just have to solve for x. So we take 15 squared. 225 plus x squared equals 289. Now is when we would subtract. So x squared equals 64. Again, to get x all alone, we have to square root, and we get x equals 8. So we have a radius that has a length of 8. That's all there is to it. Solve for the variable. All right, skipping ahead to number 4. This one looks a little bit different because they have the radii marked as just being r. So the part that they marked to having a length of 25 is just from the edge of the circle out to this vertex of our triangle. So it's not the whole thing, it's just this piece. So again, in order to solve it, we are going to have to set up a squared plus b squared equals c squared. This one gets a little bit trickier because one of our sides is split with a variable and a number. So one of our sides of our triangle, well, let's just talk about it. What's going in for A? Okay, we can put 45 in for A. Okay, that's not our hypotenuse because it's not across from the right angle, so it could go in for A. What about B? No. What did they use to label it instead of a B? R. Okay, R squared. So in order to get the whole hypotenuse, we would have to add 25 plus R. So what that looks like is we have to put it in parentheses and then it gets squared. If you would rather write the R in the front, you can. So we could write this as R plus 25 instead of 25 plus R. It's the same thing. We're still adding them together. And then that whole quantity gets squared. The next thing we have to do is go through and simplify what we can. So on the left side, that just means squaring 45. 20, 25. Whoa. Plus R squared equals, now on the right side, when we have a set of parentheses squared, we have to multiply that set of parentheses by itself. When we do that, we have to double distribute. So if we distribute the R first, R times R is R squared plus R times 25. 25R. Then we have to distribute the 25 from this first set. So 25 times R is another 25R. 25 times 25 is 625.
I don't like this.
When we go to write that over here, we're going to go ahead and combine like terms from what we've got right here. So r squared plus 50r plus 625. Now, I need to get any r's on the same side. So, if I want to move this r squared term, I'm going to have to use what operation? Subtraction. But if I subtract it from one side, I have to subtract it from the other. Now, what happens when I do that? They cancel out on both sides. So now we don't have r squared anymore. We just have 2025 equals 50r plus 625, and this gets a lot simpler to solve. We won't have to use square roots. What do I do to get r alone? Subtract the 625. So we have 1400 equals 50r, my last step. Divide by 50. R equals 28. So my radius is 28. We're going to start this one off, and this is all we're given initially. So we're going to have to use what we're given, and we are going to be solving for side AB. So I'll label that side with an X. That's the one we're going to try to find. Now when we do this, we've got two blank spots. One of them is where I put the X for side AB, but we also don't have a number labeling from C to the edge of the circle on this side. Keon, what do you think?
Oh, I have a question.
Okay, what's your question?
Well, now that you split it up, I was going on that. I thought the hypotenuse had to be longer than the leg.
You're correct. The hypotenuse does have to be longer than the leg. But 8 is not our whole hypotenuse. It's just a part of it. It's not necessarily half, it's just a part.
So we're gonna go with it on the last one again?
Not exactly. Because if I labeled this X, this is not going to be the same length necessarily as AB. I should know what this is, though. What type of segment is this? It's a radius. Do I have another radius already labeled?
Yes.
What is it?
CA.
CA is labeled 12.
12.
Any radius has to be congruent to any other radius around the whole circle. All your radii are congruent. So I can label that piece as also having a length of 12. So even though that wasn't filled in for me right away, I already have to be able to know that information. Do we have questions about how that works? Okay, so now we're going to use our Pythagorean theorem. A squared plus B squared equals C squared. What do we want to plug in for A? 12. Works for me. What about B? Okay, we should sub in that X that they gave us. Very good. Equals 20 squared. How did we come up with a 20? We had to add the 12 and the 8 together to get the 20. Questions about setting up our Pythagorean theorem? Moving on, we need to square 12. 144 plus x squared equals... I think one person said it. 400. To get x alone, I need to subtract the 144. So x squared equals 256. Last step is to square root x equals 16. So like Keon was saying earlier, the hypotenuse does have to be the longest And once we add them together to get the whole hypotenuse, 20 is bigger than 12 and is bigger than 16. Next on the back, we've got notes about a tangent segment. A tangent segment touches a circle at one of the segment's endpoints and lies in the line that is tangent to the circle at that point. And they've got a picture for us here. So our tangent segment would just be segment AB, just from A to B. So it's inside of a line that is tangent to the circle. So AB as a segment is a tangent segment. We have to know the difference between a segment and a line. If it just says tangent, it's usually referring to the line. But if it says tangent segment, we're just talking about that piece. All right, we've got one more theorem to add to these notes. If two segments from the same point outside a circle are tangent to the circle, then they are congruent. So we have two different tangent segments that have a common endpoint outside of the circle. In a sense, they almost form like an isosceles triangle if we were to connect those points. So both of those tangents are congruent if they have the same point outside the circle as one of their endpoints. Now, we just had a theorem that said if two lines are tangent to the circle with the common endpoint outside the circle, they are congruent. So what's x?
20.
X is 20. So that's it for number 5. On number 6, what are we going to have to do?
Set them equal to each other.
Set them equal to each other.
7. X equals 7.
X equals 7.
We haven't solved it yet. What do I have to do to solve it? We have to subtract 4 from both sides and then divide by 2. We end up with x equals 7.